Now, paano naging 36 ito? Tapos ginawa niyang broken line. Ang ibig sabihin nun, ito ay magiging converted to concentrated load. So yung 36, that is equal to the 3 multiplied by 12. Okay? Yan ay para sa rectangle. Yan yung 36. Next, yung 18 naman na converted to concentrated load. Yan ay para sa triangle, which is the area of the triangle, which is 6 minus 3, magiging 4 times 12. Okay? 4 times 12 will give you 36. 36 divided by 2 will give you 18 kilonewton meter. Next is, dito naman, sa lower rectangle, ito, that is 2 kilonewton per meter multiplied by 12, magiging, 2 kilonewton meter multiplied by 9, okay, 9 yan, would give you 18 kilonewtons. Next is, ito. So, paano nakuha yung 18? It is this height of the triangle, which is 4, no? So, 6 minus 2 would give you 4. Okay, so 4 times 9 divided by 2 would give you 18 kilonewton. Take note na this is always area of the triangle. Next is, dapat alam mo na ngayon yung lever arm ng mga concentrated loads. Again. Okay, so let's take now moments at B dito. Taking moments at B, you can easily solve reaction at A. Okay? So, 15 times A. Saan nakuha yung 15? That is 9 plus 6. Okay, so 15 times RA. Note na this is positive dahil it will cause a clockwise direction. Minus 36 times 12. Yung 36, ito yon, no? Yung concentrated load from this lower rectangle. And then minus, dahil it will cause a counterclockwise rotation. Next, you have 18. Minus again, dahil counterclockwise direction. The lever arm is 10. Saan nakuha yung 10 na yan? From this. That is the lever arm from point B to yan. Okay, so that is your 10. Paano nakuha yung 10? So that is 6 plus this distance, which is 4. Paano nakuha yung 4? Okay, that is 1/3 of your 12 meters. Okay, so 1/3 of 12 would give you 4 meters. So 4 plus 6 is 10. Next is 18 minus 3. Take note na si 18 would cause a counterclockwise direction again. Saan nakuha yung 3? It is this distance to the axis of rotation. Yan yung 3. Paano nakuha yung 3 na yan? That is 6 meters minus 3. Obviously, that will be 3. Okay, and then finally, you have 18 times 1.5. Yung 1.5 na yan, that is again the distance from your axis of rotation, which is 1.5. So 4.5 minus 3 will give you 1.5. From this, you can get now the reaction at A. Next, if you will look at the figure, wala kang horizontal loads. Pwede kang mag-solve kaagad. Summation forces vertical equal to 0, and you will get the reaction at B, 43.8. For example 2.4, again, determine the reactions. Notice na meron tayong mga uh, triangular, uniform load, tsaka um, angle load at 30 degrees. So, i-convert mo ito ng mga concentrated loads using superposition. Dahil kapag na-convert mo na siya ng mga concentrated loads, you can proceed to summation moments. In this case, meron tayong 4 kilonewton acting at 30 degrees. So we will break that into its horizontal and vertical components, which is 3.464 yung kanyang horizontal component, and then 2 kilonewton meter yung kanyang vertical component. So solve natin kung paano niya i-break down yan. Okay? Dahil hindi mo pwedeng i-substitute yung 4 kilonewton kaagad sa summation moments. Remember na ang summation moment, ang lever arm is always perpendicular to the direction of your force. Ngayon, yung 4, hindi yan perpendicular. Dapat i-break natin siya. Okay, so ganito ang trick. Ito yung 4 kilonewton, so i-break natin siya ng horizontal tsaka vertical. So remember na meron tayong triangle na 30 degrees. Tapos, and then let's say this is y, this is x, and this is your hypotenuse. So, remember na sine of 30 degrees is equal to opposite over hypotenuse. Likewise, cosine of 30 degrees is adjacent, which is x all over hypotenuse. So that is the SOHCAHTOA rule in trigonometry. So in this case, let's take this as downwards, and then this is leftwards. So y, from this equation now, y is equal to h sine of 30. Likewise, x is equal to h cosine of 30. Now, we substitute. So, mangyayari dyan, yung hypotenuse mo, let's say, yan yung 4 kilonewton. So, let's say, force y is equal to, let's take this as your force y, or the vertical component of your 4 kilonewton. Remember na this is your force, okay? Force is your 4 kilonewton, Fy is the vertical, and then Fx is the horizontal component. So Fy now becomes F times sine of 30, or this is 4 times sine of 30. This becomes now 2. Ito naman, Fx is now 4 cosine of 30. 4 cosine 30 is equal to 3.46. Yeah. So that's how your 2 kilonewton na downwards at saka 3.464 was taken. Okay, so let's continue solving this. Summation moment B now is equal to 0. So always start with your reaction. 6 times RAV minus 6 times 8 from point B. 6 is 8, and then 9, which is this, times 4 meters, plus 8, which is this, times 2 meters, plus 2, Ito na ngayon yung vertical component ng 4 kN, which is acting at 4 meters plus 3.464. Note na yung distance is always, or the lever arm is always measured perpendicular to the direction of force. Kaya magiging 2 meters yan from point B. Okay, ayan. So, reaction AV is 8.845. Summation forces horizontal equal to 0. Obviously, lahat ng nandyan ay vertical loads. You only have one horizontal load, which is 3.464. Obviously, this is the same as your reaction at A horizontal but different in direction. So, magiging 3.464 din siya. And then summation moment at A, this time you can easily solve reaction at B, which is 6.155. As a check, summation forces vertical, lahat ng vertical, RAV tsaka RB, should be equal to loads, which is 25 kN. Ngayon, yung 25 kN mo, yung mga vertical lang, 6, 9, 8, tsaka yung 2. For sample 2.5, ang bago dito ngayon ay yung link. Remember that a link is composed of hinges at both ends, no? So, ibig sabihin, hindi ito nagtra-transfer ng moment. Okay? But, you can transfer here loads, which is either compression or tension. That means summation forces vertical equal to 0, summation forces horizontal is equal to 0, applies to links, but not moments. Summation moments is equal to 0 at joints, pero pagdating sa link, hindi na to nagtra-transfer ng moments. Okay, so determine reactions for the beam. CD is a link joining segments ABC and DE. So it says here, isolate each segment as a free body. So we have here ABC, tsaka DE. Yan. Dito sa C tsaka D, notice here that we have R sub D. Okay, this is also R sub D. Okay, reaction D, this is reaction D. They are basically the same but opposite in reaction. Ngayon, bakit niya ginawang D yan? Kasi, hindi ito external load. Okay? This is also not external load. This is link. So, pwede mo siyang sabihin na link load. Reaction at point D. But take note that D is not a support. So, in-split niya siya into two different free bodies. So, taking DE as a free body, ito. So, ang unknowns natin dito ngayon magiging reaction A, reaction B, reaction D, and reaction E. So, separate free body CDE. Now, look at these two figures. Let us analyze figure ABC. Notice na si figure ABC, meron siyang two supports. Okay, so merong pin support, tapos may roller support, and then you have the link at D. Okay na yan kasi stable na yung figure na yan. Dalawang support. But look at figure DE. Okay, so this is A, B, point C. Then figure DE. Notice na at point E, this is also pin support. Okay? That's basically pin support kasi, ayan. Meron kang ang wall dito, pero meron kang figure na ganyan. So, that is the same as pin support. If you will cut the link DE, okay, ano mangyayari dito sa, if you will cut the link CD, what would happen to figure DE? Unstable na yan, di ba? Unstable na yan. So, you have to break this down into a separate free body. Pero, maglalagay ka dito ng, assume mo yan na support para maging stable itong separate free body na yan. So, remember, a free body should be stable. Okay? Ito, separate free body, stable yan dahil dalawang support. Also, take note na a body to be stable, dapat it should have at least 2 supports. Okay? Ngayon, look at this DE. Meron siyang 2 supports. Okay? 2 separate ends. Okay yan. Pero paano kung ganyan sana, fixed? Meron kang isang support dito, pero dito wala. Is this body still stable? Yes, dahil fixed yan. Hindi to basta-basta mag-bend. Okay? So, ito, dalawang support, pero actually, ito ay hinge, ay ano siya, link support ang tawag dyan. Alright? So, this is new link support. Since kinonvert na natin to as reaction D, summation moment at E now becomes 0. 8 times RD minus 16 times 5 is equal to 0. So, reaction D is 10 and then summation moment D. Reaction at E is equal to 6. And then ABC as free body. Dito na tayo. Reaction A is 1.75 and then summation moment at A still here. Reaction B is 35.25. Okay, let's try to solve this problem. Pero, tatanggalin na natin yung link support. Instead, gagawin na lang natin siyang hinge. Would it still give us the same reactions A, B, and reaction E? Okay, so we will try that. For problem 2.6, so this is a similar problem. Meron tayong hinge, pero meron tayong uniform load, wherein the hinge is inside the uniform load. So the trick here, just like in figure 2.5, example 2.5, ini-split niya into 2, and then make sure that one figure has at least 2 supports. Ito, dalawang support. Yan, dito naman, yung link, it acts as a support. Likewise, dito naman, yung separation niya is usually at the link or hinge. Okay? Dito ngayon, yung kanyang separation. So, figure AB, yan ay isang free body. And then figure BD, that is another free body. If you consider AB as the free body, yung hinge at B magiging parang hinge support. Kanina, link support. Dito naman, magiging hinge support na siya. Kaya, reaction B. Okay? Basta sinabing support, laging letter R. Now, with regards to figure free body CD, ito magiging R sub B. Okay? So, from figure A, yung reaction B na pataas, paglipat mo sa kabila, magiging opposite direction na sila. Magiging pababa na ito. So, from there, you can solve already. Okay? So, that's it.